7th graders, it's Mrs. Tremblay. Today's lesson is all about stem and leaf plots. I know we have box and whisker plots, stem and leaf plots, some silly little names for graphs here. That's what a stem and leaf plot is. It helps us to organize data in a data set. And what's nice about a stem and leaf plot is it lets us see how many values fall into a certain number range, and we can see the little individual values too. As a teacher, it's nice to see values in stem and leaf plots for test scores. It can let me see how many people got an A on the test, but it'll let me see how many of those A's were 90% versus 99%, because there's a big jump between those two. So that's kind of when we would use one. We're going to first learn how to make a stem and leaf plot, and you don't need to turn your page, but I'll just kind of show you. This is what a stem and leaf plot looks like. We have stems to the left, leaves to the right, kind of a little lowercase t looking thing here to set up your graph. So what we want to do is take the data values in this table and put them in a graph that looks sort of like that. So the steps are listed out for you. Sorry, let me just stack those a little bit better. The steps are listed out for you. Rather than reading them all first, we'll just take it step by step and create one. So here we have the length of 12 cell phone calls. So actually talking on the phone, not just texting. I know, I like to text too because I have 2 little children at home. And a lot of the time they're too loud for me to be able to make a phone call. But these are actual phone calls. So we want to make a stem and leaf of the amount of time each phone call was. Your step 1 is to put these data values in order. So let's do that. When I look at this, I see the lowest data value here. The shortest amount of time for the phone call was 2 minutes. So I'm going to cross off that 2 and just write it up here. And the next lowest was 3. And again, you should be writing everything that I write. 5, there's a 6, there's another 6. Be sure to include repeating values. It is necessary. After the 6, I think we have, 10, and we have a 14, we have an 18, and there's a 23, there's another 23, put them both, please. We have a 30, and we have a 55. For me, the 55 minutes would be Mrs. Galena. Her and I like to chat it up a lot. I'm sure you'll have that figured out immediately. We're pretty good friends there. She's my BFF. So, yes, 55 minutes. I'm sure you could think of a person that you would talk to for 55 minutes. And the 2-minute check-in. I'm at so-and-so's house. I'll talk to you later. Bye. Okay. So that's step 1. Order from least to greatest. And now we want to make our little T chart. So we said before it looks like a lowercase t, I guess, with an elongated right side. And we're going to write the stem on the left and the leaf or leaves on the right. And basically all the stem is it tells us what the data values start with, and leaves tell us what the data values end with. So in your stem, I think that's the trickiest part, and that's our step number 3. It says use the lowest value and the highest value to help you choose the stems. Then we're going to write them in order to the left of the vertical line from least to greatest. Toughest thing. When you're looking at the data values, I see my lowest is 2 and my highest is 55. When you're choosing a stem, I'm going to want this to kind of be in the same place value spot, I guess. A lot of people look at this and want to make it a 2 and say, well, 2, 3, 4, 5. This number starts with 2, but it also ends with 2. And it can't be a stem and a leaf. This one, yeah, I could use 5 to start because it starts with 5 and it ends with 5. But I can't write 2 for this one. So I guess if you look at this in terms of place value, that's the easiest way to go. If I was going to count backwards from the highest to the lowest, which is what I suggest you do when you're trying to make your stem, in order to get to this 2, these numbers start with 5. I don't have any 4s, that's okay. And then this starts with 3, this starts with 2, this starts with 1. Technically, what do these single digits start with? Hopefully, you're thinking, well, nothing. What number represents nothing? 0. So when I go from a single digit to a double digit here, I actually need to start with 0. So all the single digits start with 0, and it looks like the highest value that it starts with is 5. So I'm going to go 0, 1, 2, 3, 4, and 5. I don't need to go 6, 7, 8, 9, 10 because there aren't any values that start with values beyond 5. So you can stop there. So in your STEM, you just want the lowest to the highest. Hopefully that makes sense. And I am going to include the 4 because when I count, I wouldn't say 0, 1, 2, 3, 5. Even though there aren't any values that start with 4, it still needs to be included. All the values from least to greatest here. And now, step number 4, write the leaves next to their corresponding stem in order from least to greatest. Well, these values are already in order from least to greatest, so this will be a piece of cake. Try not to eat it. I know, yummy piece of cake. So single digits here, 2, 3, 5, 6, 6. I'm just going to write those down. Include the repeats. So there's my 2. This 0, 2 means 2. 0, 3 means 3. 5, 6, and 6. Then we get to the values that start with 1. So this is my tens range, my 10-minute range. I have 10 minutes, 14 minutes, and 18 minutes. All I need to do here is write the digit that follows the 1. So this 0 here means 10. This 14, I'm going to write 4. And this 18, I'm going to write 8. So this means I have a 10, a 14, and an 18. Next set, in my 20s range, I have a 23 and another 23. Include them both. In the 30s range, I just have a 30, so I'm going to put a 0 there. If you don't have anything in the 40s range, don't write a 0 there because it'll look like you have a 40-minute phone conversation when you didn't. And last, we have 55. So again, stems, what they start with. Leaves tell me what it ends with. And it says to include a key so that the user knows what they're looking at here. When you make a key, write the word key, and choose any one of your data values. So how about 23? Sounds good. Hopefully it sounds good to you too. You can pick whatever number you want, to be honest. So I'm going to write 2. There's my 2, and then here's my little T-chart, 3. So my stem is 2, my leaf is 3, and when you see that, it means 23 minutes. You should include the unit of measure here. That's it. That's how you create a stem and leaf plot. We'll talk about some common mistakes and errors that we see in class take place, but that's the gist of it. Okay, so turn your page. Now what we want to do is we want to be able to interpret the stem and leaf plot. And interpret just means I want to be able to understand what it means and to answer some questions about it. So here's a stem and leaf plot that shows some different test scores. And we can see that, okay, this 6 doesn't mean someone got a 6. That's my stem. So this is the 60-point range, the 70-point range, the 80-point range, the 90-point range. And then looking at this, I know that some people might think, well, this should be a 1, and then 100 would be 2 zeros. When you're making your stem, we said we needed to count in numerical order, right? Would you say 6, 7, 8, 9, 1? You wouldn't. 6, 7, 8, 9, 10. And then this 0 lets me know that it starts with 1, 0, 0. If we got 101, I'd put a comma and a 1, and that 1 would mean 101. So just keep that in mind for future reference. I know some that we do in class will kind of model this. And there, of course, is a key that shows me this means 92 points. Letter A asks you, how many students took the test? Well, in order to figure out how many students took the test, I just need to know how many leaves there are, because each leaf represents a data value, right? These numbers here, the stems, tell me what they start with. Nobody got a 6, but somebody did get a 66. Nobody got a 7, but somebody got a 70, and a 75, and a 77, etc. So if I ask you, what's the total number of students that took this test, or how many values are in the data set, all you need to do is count the leaves. So write that, write count leaves. Then you'll remember later on when you're looking back to your notes thinking, how do I do this again? Oh yeah, I count the leaves. Don't try to do that on a tree. It'll probably take forever and ever. But on this, it's not too bad. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18 students took this test. That's a small little class of people, huh? We probably have 34 in ours, I'm guessing. Letter B, how many students scored less than 80 points? Okay, so less than 80 points. Is 80 less than 80? No. Is 81 less than 80? So that means I need to go backwards here. The only values that are less than 80 will be these values that are underneath the 80s. So there were 1, 2, 3, 4, 5 students. 5 students. So again, we counted the leaves that were underneath the 80-point range. Letter C asks you, how many students scored at least 90? Let's say you said, what do I need to do to get an A this quarter? And I said, well, you need to score at least a 90 on the test. What does that mean you need to get? It means you need to get a 90 at the lowest, right? Would it be okay if you scored higher than 90? Sure. At least 90 means 90 or higher. So in looking at your stem and leaf plot, 90 or higher happens here. So that would be 1, 2, 3, 4 values. So 4 students scored at least 90 points. Letter D, I ask you, how are the data distributed? It sounds like a fancy question. It's not really a fancy answer. In looking at the stem and leaf plot, let's pretend that these little leaves are Jolly Ranchers. And I have 5 students sitting across the front row. And I start handing out Jolly Ranchers to these 5. So this person gets 1 Jolly Rancher, this person gets 4, this person gets 9, this person gets 3, and this person gets 1. Would you say that I distributed the Jolly Ranchers evenly? No. You'd probably be quite upset and say, hey, that person got way more than all the rest. Yeah, that's how data is distributed. So when you look at this stem and leaf plot, do you see how the 80s range has way more than all of the rest? That's the answer to the question. So when I ask you, how are the data distributed, you can just say most values are in the 80-point range. That's what you're going to write. So you go ahead. Most values are in the 80-point range. I'm trying to give you some of my best handwriting. Hopefully it's working out. My pen's starting to die on me. It just needs to make it a few more minutes. Okay, last but not least, this kind of piggybacks off of lesson 8.0 when we reviewed measures of central tendency and the spread of the data. I want you to find the mean, the median, the mode, and the range of the data. And then we're going to examine it to see if there are any outliers in there. So to find the mean, median, mode, range, let's list those out. We want the mean, the median, the mode, the range, and list any outliers. Let's start with the outliers. I think that's the easiest way to go. Sometimes it's nice to start with the easiest and work your way to the hardest. It feels nice to check things off of the list. I don't know if you're like me at all with that. I love checking things off of the list. Okay, when you look at a stem and leaf plot, it's usually pretty easy to identify an outlier because it'll be something that has space in between it. And here's what I mean. If you look at our original stem and leaf plot, you don't have to turn your page, just look at mine. Do you see how there's a gap between the 30s and the 50s? We see a space here. That means that this is kind of spaced away from the rest of the data. So when you're looking at a stem and leaf plot and you're trying to figure out are there any outliers, we can kind of look for empty spaces in between. And do you see how this all kind of flows? We have our 60s, 70s, 80s, 90s, 100. There aren't any outliers in this data. There isn't a value that's way less or way more than all of the rest. So for outliers, I'm not going to leave it blank because then I might think, Mrs. Tremblay thinks I don't know the answer. Right? None. There aren't any outliers. Nice. All right, the next easiest to find, I would say, would be range. We're going to end up going backwards on this. So for range, range is high minus low. When you look at a stem and leaf plot, to find the highest value, you look for the very last leaf, and the lowest value, you look for the very first leaf. So the last leaf, this 0, means 100, and the first leaf, this 6, means 66. So high minus low would be 100 minus 66. That means your range is 34 points. So far, so good. All right, next on the list, let's just keep going backwards, is the mode, the data value that appears the most. When you're looking at a stem and leaf plot trying to figure out what the mode is, you can't just look for repeating leaves. Because I see an 8 here and 2 8s here, but that 8 means 78, and this 8 means 88. So when you're trying to find the mode from a stem and leaf plot, you need to look for repeating values that are in the same row together. So if you're looking at just the 60s, numbers that start with 6, there aren't any there. And there aren't any repeating values in the 70s range. In the 80s range, I see that we have 2 1s, 2 4s, 2 8s. There aren't any repeating values in the 90s range, and there aren't any in the hundreds range. So in looking at this, 81 appears twice, 84 appears twice, and 88 appears twice. What we have here is a three-way tie between the mode. So all three of those are modes because they all appear twice, which is more than any other number. So for your mode, don't write 1, 4, and 8. That 1 means 81, the 4 means 84, and the 8 means 88. So make sure you include your stem when you're writing your final answer there. All right, the median. There are two ways to find the median from a stem and leaf plot. One of them, and this one I tend to mess up on, so I like the other one better. But what you can do is, you can kind of still use your two-thumb method. And when you're looking at this, I know the lowest leaf is 6 and the highest, that's 0. The next lowest is 70, the next highest is 99. The next lowest is 85, 92. 77, 90. 78, 89. 81, 88, 81, 88, 83, 86. And I see that I end up, for the middle, having these two 4s. That doesn't mean that my median is 4, because this 4 means 84, right? And when you have two numbers in the middle, aren't you supposed to find their average? Well, the average of 84 and 84 is 84. If we had two numbers that we didn't know, then we would add them together and divide by 2. But in this case, because they're both the same, that means that the median is 84. So that's one way to do it. So I'm going to go ahead and list my 84. If you are like me and tend to kind of mess that up, I do all the time, then what I would suggest that you do is list out all the data values and then use your two thumbs. So I'm going to kind of zoom way out here. I'm going to look at my stem and leaf plot and use it to list my values in order. So in this stem and leaf plot, this 6 means 66, and then I have 70, 75, 77, and that's what I'm talking about here. So across the bottom, and you should do this too just so that you have another method. I have a 66, a 70, 75, 77, 78, 81, 81, 83. Keep going, keep going. I know, it's a lot to write. It's so worth it though. So much fun. And 100. So basically all I did was I looked at the stem and leaf plot and listed out all my values from least to greatest. And now we can go ahead and work our way in. Which, doing it this way, I think is a little bit easier than trying to do it on the stem and leaf plot. But it's up to you. If it works for you, then go ahead and do it the other way. But again, we see we have two values in the middle. That happens when we have an even number of numbers in the data set. If you had two numbers that weren't the same, you would add them together and divide by 2. And that would give you your median. So there we have it. All right, there aren't any outliers in this data set, so when we find our mean, it should be pretty close to what the median is. To find your mean, remember you have to add them all up because it's so mean and time consuming. You add them all up and you divide by the number of numbers that you added. Personally, if you have these all listed out, I think it would be a lot easier to add from this data set. So 66 plus 70 plus 75 plus 77, all the way up to here. Hit enter, and I'll just give that to you. So I guess it's not as mean. We get 1,511 when you add them all up. I usually add them up twice to make sure I get the same number both times, so I know I didn't make any mistakes. Yes, even I do that as a math teacher. I still do it twice. Alright, so after you add them all up, that's not the average. You need to divide that by the number of values in the data set, which we already said 18 students took this test. When you do that, zoom back in a little bit here, you end up getting 83.94 repeating. I want to round it to the nearest whole number. So I'm going to use almost equal to because I'm rounding. So 83.94 repeating is pretty close to 84. So yeah, the mean and the median are pretty much right on because there aren't any outliers messing up our data. Now, one last little thing. Let's say you didn't list all these values out. When you're trying to find the mean from a stem and leaf plot, all I would do is have my calculator handy and type in not 6 plus 0 plus 5 plus 7 plus 8. You would type in 66 plus 70 plus 75 plus 77 plus 78 and keep going. Hit enter and then divide by the number of values in your data set. You are done. Finally. See you tomorrow.